Good morning, students. Today we will do part 2 of the introduction of triangle. Median, altitude of a triangle and exterior angle property of the triangle. Let's start. Median of a triangle. We know in a triangle there are 3 vertices and 3 sides. Let's consider this triangle as ABC. Now mark M as midpoint of BC. Midpoint means BM is equal to CM. Let's understand what is a median. Vertex opposite to side BC is A. You have to join this vertex to the midpoint of side BC. That is the line segment joining the vertex to the midpoint of the opposite side. This line segment is called median of a triangle. Let's recap. In a triangle, if we take this vertex and midpoint of the opposite side, then the line segment joining the vertex to the midpoint of the opposite side is called a median of a triangle. In a triangle, there are 3 vertices. Therefore, if you join midpoint of this side to this vertex, then it is again a median. And similarly in this case. Okay. Therefore, a triangle has 3 medians and they intersect at one point. If we have 2 intersecting lines, we say the word intersecting. If we have more than 2, then it is called concurrent lines. Let's understand. We have 3 medians. These 3 medians intersect at one point, means they are concurrent at a point. This point is called centroid. 3 medians always meet at a point and this point is called centroid. It is inside the triangle. This is concept of median of a triangle. We have also used the word median in data handling, but that was related to data. Now we are doing not just median of a triangle. It is the line segment joining the vertex to the midpoint of the opposite side. Now let's understand altitude. Altitude of a triangle. Altitude means height. And altitude is a segment drawn from the vertex of a triangle perpendicular to the opposite side. We have taken 3 different triangles: acute angle triangle, right angle triangle and obtuse angled triangle. There are 3 different cases because median was very easy, but in altitude you have to understand in 3 different aspects. Let's start with acute angled triangle. In acute angle triangle, this is the vertex and this is the opposite side, this one. If you draw perpendicular from this vertex to the opposite side, this is an altitude. Remember, median was that it is joined to midpoint. Now we are doing altitude. It is perpendicular. Now, but in right triangle, what happened? If we take this vertex and this side, then you know this is already perpendicular. So we don't need to draw any other perpendicular. It is already perpendicular. Therefore, this side itself is an altitude. Similarly, if you take this vertex and this opposite side, then from there, this one is perpendicular. It is the side itself. Hence, this side is also one of the altitudes of right triangle. And the third one will be from here. Okay. These are the 3 altitudes of right triangle. Now, let's understand in case of obtuse triangle. In obtuse angle triangle, if you take this vertex, you want to draw perpendicular on the opposite side, but this is not possible. How will you draw? Perpendicular is always in falling direction. Therefore, it will be here in extended part. Perpendicular can be drawn to the extended part of the line. Okay, line can be extended. This is the perpendicular. So, we observe that in obtuse angle triangle, perpendicular is outside. That is, altitude is outside the triangle, because altitude is actually the perpendicular from the vertex to the opposite side. So, in acute angle triangle, perpendiculars, or we can say the altitude of triangle, are inside. In right triangle, two are these sides and the third one you will draw from here. In obtuse angle triangle, this is one of the altitude. We will discuss all the three altitudes in every case. Okay, let's do that. This is an acute angle triangle and these are the three altitudes. They are also concurrent. They intersect at one point. This point is called ortho center. Now, let's understand ortho center of right angle triangle. I already explained these are the two altitudes and this is the third one. These three intersect at this right angle vertex. So, this is the ortho center of right angle triangle. Now, for obtuse angle triangle, I told you, if you want to draw perpendicular from this vertex to the opposite side, then it will be outside. This is one, and from here you can draw this perpendicular. But similar in this case, when you will draw altitude from this vertex, it will be again outside. Okay, so all two are outside and one is inside. So it is not possible for them to intersect inside. We can extend them. I have extended this one, and this. These three intersect, or we can say they are concurrent outside the triangle. So ortho center of obtuse angle triangle is outside. Now students, we will do exterior angle property of a triangle. Let's see what is an exterior angle. Exterior angle. When you have a triangle and you extend one of its side, then the angle between side and the extended line is called exterior angle. Here you can see exterior angle. This is the exterior angle here. Now let's understand what are interior opposite angles. If we have only the word interior, a triangle has three interior angles. But it is interior opposite angles. It means you have to leave this angle. If this is the exterior angle, then the angle adjacent to it, leave it. Two interior angles will remain. These are called interior opposite angle with respect to this angle. And sum of the two interior opposite angle. If you will add these two interior angles, you will get this. What is exterior angle property? Exterior angle of a triangle is equal to sum of the interior opposite angles. See this. Exterior angle is equal to sum of interior opposite angles. A triangle has three exterior angles. So, every exterior angle will be equal to sum of the interior opposite angle with respect to it. Now, let's do a sum. Here you can see 2 is the exterior angle because it is angle between the extended line and the one side of a triangle. Now, angle 2 is equal to sum of the interior opposite angles, that is 30 plus 42 degree. 72 degree. In this way, you can find the exterior angles of a triangle using the exterior angle property. Let's recap. We have done median, we have done centroid, next altitude, orthocentered and exterior angle property. I hope you understand these concepts and you will be able to apply them. Thank you, students.